review of the Edgenuity lesson central angles. So for example 1, it says find the value of x, and the lengths of the segments are listed over here. So we have two central angles here, angle BAE right here, and angle EAD, because they're central angles because their vertex is coming from the center of the circle. These marks in here mean that these two angles have the same measure. Now, when that happens with your central angle, two things occur. First, these arcs out here, arc ED and arc BE, are going to be the same measure, as well as if we connect the endpoints of the vertex of our angle, these segments here, the chords, end up being the same length too, just because these central angles are congruent. So because I know that EB has to equal ED, we can just set these equal to each other and solve. So I'm going to add 24.
Yo, Miss Snow.
And then I'm going to subtract x from both sides, and then divide by 2. So x would have to be 17. Okay, looking at the next one, it says that segment QR is tangent to circle P. So since this is tangent, I automatically know that if you connect it to the radius, it makes a right angle. It's perpendicular right there. So we need to find the measure of angle R. So because we know that this is perpendicular, it makes a right angle, which means this is 90 degrees. And remember that the angles in a triangle have to add up to 180. So 53 plus 90 plus the measure of angle R has to equal 180. So if we subtract off the 53 and the 90, we'll get 37. It's 37 degrees. Okay, looking at the last one here, it says, for segment ZY to be tangent to circle X, what must be the length of segment ZY? So again, for this to be tangent, we would have to have a right angle here. And this time we're not dealing with degrees, we're dealing with the lengths of the segments. So remember when you have, I'm just going to put this here, because that's what we want it to be, a right triangle, you can do the Pythagorean theorem to help you figure out a side length. And remember, it's a squared plus b squared equals, and this is always the hypotenuse squared. So our hypotenuse opposite the right angle is the longest side right here. So our hypotenuse is 17. Now, you might be looking at this going, well, I don't have lengths for either of the other sides. So let's go ahead and call this one B. But looking here at XY, it's the distance from the center to the side of the circle, which is a radius. So if this is the distance from the center to the side of the circle, this also has to be 8. Any radius that you draw would be 8 inside the circle. So we'll go 8 squared plus b squared equals 17 squared. So if I square those and then subtract 64 from both sides, and then we're going to go ahead and square root 15. So for this to be a right triangle, this has to be 15.